All right, today we're going to be having a look at the exercise on parallel and perpendicular lines. So a couple of things we want to remind ourselves is, for example, in question 1, parallel lines have the same gradient. So if we were having a look at 1c, well, we've got the line y equals 2 on 3x plus 6, and the gradient of that line is 2 on 3, which means the gradient of the line parallel is also going to be 2 on 3 because they have to have the same gradient. Now, we know all lines exist in the form y equals mx plus c, and we're told it passes through the point 0 minus 5. Now, we know the gradient of my line is 2 on 3x, and we're plussing c. So all I've done is replace the gradient with 2 on 3. Right, now we're going to substitute in the point. Y is minus 5, x is 0, plus c. Now that goes away, and we're left with c is equal to minus 5. Therefore, my equation is y is equal to 2 on 3x minus 5. Sorry, 2 on 3x. Let me delete that funny 3 there. 2 on 3x minus 5. Okay, let's have a go at question 2. I might do 2. Let's do 2e. So we're looking at the equation of a line perpendicular. Let me just rub out some working here. If you're still working, just pause the video. So we're looking at the gradient of the line, or the equation of a line perpendicular to minus 7x plus 2. Now, when we want the perpendicular gradient, m perpendicular, we flip our gradient upside down. So if you flip minus 7 upside down, you get minus 1/7, and we get rid of the negative. So it's 1 on 7. So my equation is y is equal to 1 on 7x, and we are plussing c. Now we're also passing through the point 0 minus a half. So let's substitute that in. Minus a half is equal to 1 on 7 times 0 plus c. That goes away, and we're left with c is equal to minus a half. So therefore my line is y is equal to 1 on 7x minus 1/2. Okay. Let's have a think of question 3. Question 3 really is going to require some thinking. And it's going to require our knowledge on the gradient of vertical lines and also the gradient of horizontal lines. Now, a horizontal line is a line going straight from the left to the right, and it has a gradient of 0. So if we have a look at, I might do 3b and c. So 3b, we're looking at a line parallel to x equals minus 2. Now, the line x equals minus 2 looks something like this. It's a vertical line that passes through minus 2. And it has to pass through the point 3. The only vertical line that passes through the point x equals 3 is the equation x equals 3. No other vertical line will pass through the point 3. If we look at c, we're looking at perpendicular to y equals minus 3. Well, the line y equals minus 3 looks something like that. It's a horizontal line, and a perpendicular line would have to be vertical. So it's going to have to be some vertical line. Now, again, the only vertical line that passes through the point 2, 0 is the line x is equal to 2. And that's the answer. Okay, question 4. Let's have a look at 4a. We're parallel to the line y is equal to minus 3x minus 7, and we're passing through the point 3, 0. Now, a gradient parallel to that line has to have the same gradient of minus 3. Now we've got y is equal to minus 3x plus c. Right, this is going to be a bit different because this point here is not the y-intercept. So I'm going to write it down, and we're going to substitute it in. This time 0 is equal to y, and we've got minus 3 times 3 plus c. That gives us 0 is equal to minus 9 plus c, which means c is equal to 9. So therefore my equation of the line, we've found the y-intercept is 9, is minus 3x plus 9. Okay, let's have a go at 4c. Now we're perpendicular to the line y equals 5x minus 4, and the perpendicular gradient to 5, we flip it upside down and we put a minus out the front. And we're passing through the point 1, 6. So y is equal to minus 1 on 5x plus c and we're passing through the point 1, 6. We substitute that in y is 6, minus 1, 5, times x is 1, plus c. Okay, now if we wanted to convert these to decimals, you don't have to, but this is equal to, 6 is equal to, that's minus 0.2 plus c. And if we plus the 0.2 to the other side, we get c is 6.2. Right, so therefore, we've found the value of c, so y is minus 1/5x plus 6.2, or you could say 6 1/5, or that's going to be like 31 on 5 as well. Okay, I might do question 5, and then I think we're done. Let me rub some stuff out. Okay. Right, so we've got to find the equations of each of the sides of this triangle. Well, easily this first one, this side here, is just the line y is equal 0. So that's side 1. Let's look at side 2. Now, to find the equation of a line, we need its rise over its run. And this one here has a rise of 3 and a run of 3. So the gradient is rise over run, and it's going down. So the gradient's minus 1. So we're looking at the gradient between the points 0, 3 and 3, 0. If we start here and go to here, we're going down by 3. My rise is 3, and we're going across by 3. My run is 3. Now the y-intercept of this line is 3. We can see that on the diagram. So the equation of the line is minus 1x plus 3. If we look at the other side, it's really going to be the same thing. The rise over the run between these 2 points, well, we're going across by 3, so my run is 3, and my rise is also 3. So the rise over the run is going to be 3 over 3, which is 1, and it's going up, so it's a positive gradient. So 1x, and the y-intercept there is 3. All right, hope that makes sense.